For decades, rumors have swirled about a new aircraft, one so fast it seems to defy physics. This is the SR-72, a phantom successor to the legendary Blackbird, designed to reach speeds once thought impossible. Nicknamed Darkstar, it conjures images of a sleek black craft streaking through the upper atmosphere. The SR-72 has captured the public imagination, especially after its fictional debut in Top Gun Maverick. Its real-life development is shrouded in secrecy, fueling endless speculation. More than just military hardware, the SR-72 is poised to become a cultural icon, much like its predecessor. It promises a future where distance is no barrier, and intelligence can be gathered in the blink of an eye. In a world where threats emerge instantly, speed is a powerful advantage. The SR-72 isn't built for dogfights, it's an eye in the sky, able to reach any point on the globe in record time. Its existence could reshape global strategy and redefine air power. The legend of the SR-72 is just beginning, but it's already changing how we imagine the future of flight. To understand the SR-72, we must look back at its legendary forerunner, the SR-71 Blackbird. Developed in the 1960s by Lockheed Skunk Works, the SR-71 was a marvel, flying above 85,000 feet and exceeding Mach 3. No Blackbird was ever lost to enemy fire, a testament to its speed and engineering. Its titanium airframe and astronaut-like pilots made it a futuristic icon. But as satellites rose and costs soared, the SR-71 was retired in the late 1990s. Satellites, however, have limitations. They're predictable, and adversaries know when they're overhead. This left a gap in intelligence gathering, especially as global threats became more complex and time-sensitive. The need for a new, faster, more flexible aircraft became clear. The SR-72 isn't just a replacement, it's a leap forward, aiming for Mach 6 and beyond. It builds on the Blackbird's lessons, pushing into the hypersonic realm. The SR-72 is the next chapter in the story of high-speed flight. Hypersonic flight means traveling at Mach 5 or faster, over 3,800 miles per hour. At Mach 6, the SR-72 could cross the Atlantic in under an hour. Achieving these speeds is a massive challenge, especially for propulsion. Conventional jet engines can't handle hypersonic airflow, they'd tear themselves apart. Enter the scramjet, an engine with almost no moving parts, using the aircraft's speed to compress air for combustion. Scramjets only work at very high speeds, so the SR-72 needs a secondary engine to get up to speed before the scramjet takes over. This combined cycle engine is a key technological hurdle. Heat is another major challenge. At Mach 6, friction can melt steel. Advanced materials like ceramic composites and special alloys are essential. Sophisticated cooling systems protect the airframe and electronics. Mastering propulsion and heat management unlocks hypersonic flight. The SR-72 is designed to conquer these extremes. The SR-72, or Son of Blackbird, is envisioned as an unmanned, reusable hypersonic aircraft. Its main mission: intelligence, surveillance, and reconnaissance, with the potential for precision strikes. Being unmanned means it can fly longer, take greater risks, and perform maneuvers impossible for human pilots. Its greatest defense is speed. Mach 6 allows it to penetrate contested airspace and vanish before enemies can react. Speed is the new stealth. While it may have some stealth features, velocity is its shield. The SR-72 will use a revolutionary combined cycle engine, a turbine for takeoff, and a scramjet for hypersonic cruise. Integrating these engines is a monumental engineering feat. The SR-72 can loiter, gather real-time intelligence, and strike high-value targets in minutes. Imagine neutralizing a mobile missile launcher thousands of miles away before it can be used. This near-instant global reach is a game-changer for national security. The SR-72 redefines what's possible in military aviation. The SR-72's power comes from the synergy of speed, stealth, and autonomy. Hypersonic speed shrinks the globe and outpaces enemy defenses. Stealth features, angular shapes, radar-absorbent materials, and cooled exhaust make it even harder to detect. By the time it appears on radar, it's already gone. Autonomy is the third pillar. As an unmanned vehicle, it carries more fuel, sensors, or payload instead of life support systems. Advanced AI flies the aircraft with precision and endurance no human can match. It can make split-second decisions, optimize flight paths, and evade threats instantly. Together, these features create a revolutionary capability. Missions too dangerous or demanding for humans become possible. The SR-72 can penetrate the world's most defended airspaces, gather intelligence or deliver a strike, and return safely. It's a powerful deterrent, shaping adversaries' actions without firing a shot. The SR-72 is the ultimate tool for 21st century air power. Building the SR-72 is one of engineering's greatest challenges. The combined cycle engine must work flawlessly from runway to Mach 6. Transitioning between turbine and scramjet is a delicate, high-stakes process. Thermal management is critical. Friction at hypersonic speeds can weaken the structure and damage electronics. Engineers use advanced materials like ceramic composites and titanium alloys, and may circulate fuel through the skin to absorb heat. Aerodynamics at Mach 6 are vastly different. Stability and control are paramount. Supercomputers model airflow, and hypersonic wind tunnels validate designs. Integrating all systems, engines, sensors, flight controls, into an autonomous platform is a massive task. The flight software must manage everything in real time, reacting instantly to threats or changing conditions. Every component must survive extreme temperatures, vibrations, and forces. Progress is slow and painstaking, but each breakthrough brings the SR-72 closer to reality. The SR-72 is part of a global race. Nations like Russia and China are also pursuing hypersonic technology. Hypersonic weapons and vehicles threaten to upset the strategic balance. The first to field a reusable hypersonic platform gains a major advantage. Deterrence now means being able to respond anywhere, anytime with speed and precision. The SR-72 sends a clear message: nowhere is safe for adversaries. Its real-time intelligence and rapid response reduce the risk of miscalculation and conflict. The SR-72 is more than a weapon. It's a stabilizing force in an unstable world. The race for hypersonic tech drives innovation in materials, propulsion, and AI. These advances benefit not just the military, but society as a whole. By investing in the SR-72, America stays at the forefront of aerospace technology. In a world where speed and information are power, the SR-72 is essential. The SR-72's technology will shape the civilian world, just as military jets once revolutionized commercial flight. Hypersonic travel could one day make global journeys, London to Sydney, in just a few hours. Advanced materials and autonomous systems will improve everything from manufacturing to self-driving cars. Hypersonic vehicles could even lower the cost of space access, serving as the first stage for orbital launches. The SR-72 is a stepping stone to faster flight and perhaps to the stars. It's more than a military project, it's a symbol of human ingenuity and ambition. The SR-72 carries the Blackbird's legacy into a new era, promising to reshape security and society. The innovations it inspires will ripple through our world for decades. By reaching for the skies, we elevate all of humanity. Today, the SR-72 is a ghost, but it represents the bright promise of tomorrow.